Welcome to a lesson with Dr. Powell. So in the last video, we talked about a couple of the Frenet Serret equations, and we're going to come up with another one. So the ones we have so far are dt ds is equal to kappa n, and the other one is that dB ds is equal to negative tau n. Okay, now the third one we're going to come up with is something for dn ds. Now we know something. We're taking the derivative of a constant valued vector function, so it's going to be orthogonal or perpendicular to where we started with. So this is going to be orthogonal to n, which means it's going to lie in the plane that contains t and b. So this is going to be equal to something, whatever it is, times t, plus something, whatever it is, times b. So basically what we're going to do here is we're going to figure out what that a and what that b are. Okay, now keep in mind t and b are unit vectors and they're orthogonal to each other. In particular, if I were to take this whole thing, which is dn ds, and dot it with b, so think of a dot product b distributing through, b dot b, since b is a unit vector and it's just projection, you just get 1. And over here you get 0 because they're orthogonal to each other. So you end up just getting b. In other words, if you want to know what this coefficient is, you simply just need to be able to figure out what this is. That's kind of the idea. To get this coefficient over here, use a similar idea. If you dot it with t, take this dotted with t, the outcome is actually going to be a. So that's what we're going to use. We're going to try to find out what this is another way and what this is another way, and then just put that in there. So in order to do that, let's first start with this one over here. And this actually looks like part of a product rule with n times b. We're taking a derivative. Well, this is actually very nice because n and b are orthogonal to each other, so this dot product is just 0. So in particular, this derivative is 0. It's going to give us something very nice, but we can still do a product rule here. dn ds dot b plus n dot dB ds. Okay, so in particular, we know we have this, and this is this quantity is actually what we're looking for, right? And we know this is 0. Well, do we know this is another question? And actually we do, because from the other Frenet Serret equation, we know that dB ds is actually equal to negative tau n. And we take n dot that. And n dot n being a unit vector and projection, therefore, we just get 1. So we end up just getting negative tau. So negative tau plus this quantity is 0. So put that negative tau on the other side, becomes positive tau. So really, we get that this coefficient is simply tau. So we get tau b. Now we just got to figure out what that a is. So to do that, we do something similar. We think of this as part of a product rule. And we think of n times dot t this time. And we have, okay, so we have dn ds dot t, which is that, plus n dot dt ds. And again, using this other equation here, we get kappa n for this part, dotted with n. And notice that this n dot n again is just 1, so we get kappa. But this is equal to 0 because n and t are orthogonal to each other. So that positive kappa goes on the other side, become negative kappa, which means that this thing really is negative kappa. So we get negative kappa t plus tau b. So in the end, we end up getting our third equation, which I'll just rewrite again. dn ds is equal to negative kappa t plus tau beta, or tau b. Okay, and we're going to use this idea okay, in the derivation of a couple formulas which are extremely useful and make the calculation of curvature and torsion amazingly simple. And so we'll look at that in the next video. Thanks for watching.